Hey guys, what's up? RE1 or 0 here. Welcome to this video series on the previous OSCE CTP certification. If you don't know me, let me briefly introduce myself. I'm Bishra, aka RE1 or 0, which is my hacker name. I'm in this industry for more than 6 years. I hold a bunch of offensive security certificates, OSCP, OSWP, and OSCE. And I'm currently preparing for OSCE, which is on advanced Windows exploitation. I work at HackerOne as a senior solutions architect. Well, basically, my day-to-day job is more CN business side of hacking, pen testing, bug bounty, while at nights or weekends, I'm hacking on the offensive security side. So this is an introduction of me. If you already know my face, you would probably be familiar with my OSCP preparation series. I created it to give something back to community because in the beginning I learned a lot from this community, and to be honest, I'm not getting anything out of this. I just want to help the community who helped me in the beginning when I was a beginner. So I just want to help people who are preparing for these certifications or want to learn about specific techniques and don't know um, about your roadmap. So I have a methodology, of course. During my preparation for OSCE, the previous OSCE, it's changed now. I think it's OSCE ED for exploit development. I exaggerated a bit because I love binary exploitation, and I created around 50 exploits for different vulnerable apps. I was so obsessed with it. I was reading different people's source code and stuff, exploits and stuff. So it's my hobby, it's my passion, whatever you call it. And if you know me, you would know that I don't like to chat a lot. So I already give a long introduction of myself, and I would like to jump into the first vulnerable app, which is EasyRM to MP3 converter. There's a basic buffer overflow vulnerability there, and we will use jump ESP technique to exploit it and run a command on the vulnerable server. If we're ready, let's jump in. Cool. So as you can see, the only thing we need is a Cal Linux box, or it can be a Ubuntu box, doesn't matter, so that we will create our exploit and run the fighting code there. And this is my Windows box. We have immunity debugger, the vulnerable bit box, EasyRM. I have put it here to have SSH connection and PSFT. So first things first, I will just connect to my Cal box with the IP address of it. It's very important while you're writing exploits that you're setting these up, like SSH connection, SFTP connection, so that you can send the files or write your exploit. Of course, you can also go through two servers like Kali to Windows Kali, but it's much more easier in this way. Set this up in the beginning so you will have no headache later. As you can see, I'm like writing the basic commands. If you're not familiar with it, just pause the video and try to understand what I'm writing here. I'm just connecting to SFTP, I guess, part of the pretty app. Cool. The first thing I will do is I start writing a fighting code. To do that, first I create a file. As you can see, I just defined a variable called Kalisa. What I'm doing is opening a file. If there's no file, it's going to create it. And since I'm specifying W option here, it will overwrite the file over and over again. I continue with the .write functionality of Python to write 30K a character. And I close the file with .close option. You may not be familiar with it. It's okay. I was also not familiar in the beginning, but now you learned it. We close the file, we close Vim, sorry, and I realized that I wrote the wrong extension here, not M3U, it would be a Python file. Let's move it from M3U to PY for Python, and we will run the Python code. Cool, it should create a test.m3u file, which is just here. Awesome, and we can get it with get command from PSFTP by writing the full path. As you can see, it just got it to the desktop. Next thing I'm going to do is I'm going to run the app EasyRM and run immunity as administrator. I will attach the process now. I changed the font a bit, but it looks so ugly. Sorry, guys. I'm trying to look EasyRM, which is just here. Awesome. I'm attaching it. The next thing you're going to do is press on the play button so that it would run an immunity. So you can see all the memory details and everything. So I'm gonna load this file that I just downloaded from a Calibox, but you need to change the extension M3U. Should be there. Here we go. We're attaching the file, and as you can see, EIP address is filled with 41, 41, 41, 41, which is a hex representation of the character capital A, which is a thing that we actually try to write, right? For 30K times, meaning I can actually take control of EIP and the whole memory. This is very good. And I'm trying to see now what is the exact number to reach out to EIP, because I sent so many A's there and I don't know which order am I supposed to send it. In order to do that, I can either send a unique pattern for 30K times, or this may not be the smartest idea, but because sometimes the app crashes so much and it's not very accurate. So play with smaller pattern numbers. In order to do that, I will send 25K A's and 5K's unique pattern. As you can see, I just wrote 25K times A, and I'm sending 5K times unique pattern. In order to do that, I will use something of Metasploit module called pattern create. I'm locating it to see the full path. I'm creating 5K patterns with the -L option for length. I'm writing a number and it creates a unique pattern. I'm going back to my file and I'm including this with the .write function of Python again. Writing it in single quote. Wrote this, close the single quote and save the file. We will run the Python code again to create another test.m3u file, and I will get it with psftp again, but you can delete the previous file so that there wouldn't be any problems. I'm getting the same file with get option, and here we are. What I'm going to do is I'm going to restart the immunity debugger, the application. We restarted it. Cool. Launch the app again. Here we go, loading the file, tested M3U we just got downloaded from the Calibox. And as you can see, EIP is filled with a strange number. We can just find what this is with pattern offset, which is also the tool that you can use from Metasploit. When you write this, it gives you a unique number, 1083, I guess. Perfect. So we can actually write 25K plus 1083, sorry. So that we will fill the previous number with the character A, and then we can control the EIP for the next 4 bytes. Awesome. So I defined a new variable called string. I'm writing A for 26K83. 26,083. I'm seeing these just like separate numbers. It's incredible. And then I'm adding more characters to a string variable, and I will send four times B so that I can actually fill EIP with hex representation of B, which would be 42. Cool. And I'm writing it with only the variable string because I already attached all of the stuff that I want to see next to each other. So if I see EIP with 42, 42, 42, 42, that means I have the control of EIP now. I'm running the file again, deleting the previous file, getting the same file from psftp, the putty tool, to my desktop. I'm restarting the app, relaunching it by playing with the play button. I'm loading the file that I just downloaded. Cool. Yeah, here we go. And as you can see, EIP is 42, 42, 42, 42. I love saying that, meaning we have control of it. You can also follow it in down to see all the characters that we wanted to include for B's, and then the remaining 1000 C's and the previous A's that we found with the pattern create. That's pretty cool. All right, the next thing I want to show you guys is a immunity debugger module called Mona. It will be very useful for us. Just go to immunity and add this script and the 5 py comments. I just downloaded it on internet. You can find it anywhere because it's de facto tool, but it's not coming by default with immunity. so that we can use the following comments on immunity. I will first check for mono modules to see all the modules, and I'm looking for something with zero protection for rebase, safe as CH, ASLR, etc. So we don't want these. They create confusion, and we will learn these techniques later. This is the easiest ones. So the next thing I want to do is I want to find a jump ESP address in one of these modules without any protection. In order to do that, I will write the following code to Mona. Mona jump -R for register, which will be ESP, and the module name, which is one of the modules without any protection. That's very cool. The next thing I will do is I will save this address for EIP, which was filled with 4Bs before, and I will write this in little endian form. If you don't know what this is, you have to check it online because it's not a theory course. I'm just trying to show you the show it in action. As you can see, this is the address. We are going to write it in the little endian form, meaning you're going to start getting 2 bytes every single time and going to write them from end to beginning. The next thing we're going to do is we're going to pop up a calculator, right? In order to do that, I'm writing the following code with MSF Phenom. Again, if you're not familiar with it, please go ahead and check online what these options are. But yeah, this should be enough for you to learn the comment. I'm gonna write it in the beginning and we'll attach it later. Let's paste this here. Perfect. And what I'm gonna do is I'm gonna add a couple of nopslets after the jump ESP and EIP address. Again, if you're not familiar with nopslet, this is something you need to check online for the theory, but this is something that we're gonna use a lot if we are gonna just skip some place in the memory. So we're writing a string, and then the payload, the shellcode that we created to pop up the calculator. And I'm just sending random C's at the end of it. Awesome. We're gonna run the Python file again to create the test.m3u, the brand new m3u file. We're gonna restart immunity debugger to exploit it one final time. I'm deleting the previous file, creating a new one. Appears on desktop. Cool. I'm running MP3 converter again. It's popping up here. Awesome. Now we're going to attach this exploit one last time to pop up calculator. Let's change the extension M3U. Cool. Go into that file. And here we go. The calculator is here. Very cool. We just run comment, guys. This was the easiest scenario that you can see. We use jump ESP method. I show you the exploit here again by zooming a bit. We use pattern. We try to understand the pattern number first. We use pattern create, pattern offset from Metasploit module. Then we find jump ESP address with Mona. And we try to find a module that we can use without any protection, such as safe SEH, ASLR, etc. And then we added some nopslets to create any confusion or any errors that we can see. And then we wrote them all in our script. Then we wrote an MSFNM command to create pop-up calculator later. Instead of getting a reverse shell, we use the most basic option here. Don't worry, guys, we will have a lot of reverse shells in the future. This is the most basic scenario, just to show that we can run comments. Let me close the file, run it, and attach the immunity, and here we go. Like I said, this is the most basic scenario. Hope you enjoyed this video. The next ones will be much more complicated. We will see different methodologies in every single video. Not every single, but sometimes we will see CH exploitation 20 times or whatever, or egg hunting so many times. And there were some scenarios that you would satisfy yourself a lot by just watching. It's so cool. I remember that it took a week of me to write some of the exploits to figure out stuff myself because I was so stubborn to read somebody else's code and I wanted to do it myself. But congratulations, since you're here, that means you're not going to spend a week. You're going to watch this video because I didn't find any videos when I was preparing for CTP OSCE. But you're lucky. So hope you enjoyed this video, guys. I will start creating the next one in the next weeks. Cheers.